Good evening, everyone. My name is Ahmed, and today I am presenting my research on wireless network security, specifically focusing on how we can use machine learning to protect Wi-Fi networks. Most of us, most of us use Wi-Fi every day, but we don't realize how vulnerable it is. Even with the new WPA BA3 standard, there is a major flaw called transition mode. That allows attackers to perform downgrade attacks that forces your secure connection back to an older hackable version. My analysis of this current state of the industry shows a warning gap. While our Wi-Fi speed are getting faster, our security adoption lagging. Less than 100% of network are fully utilizing the latest protection. Let's go to the next, to the research gap and background. When I look into the background of this topic, I found a significant research gap. Most exciting security system uses static signature, basically a list of non-bad behavior, but hackers are creative. They change their pattern constantly. Traditional students also struggle with the false position in crowded areas like airport or university where there is a lot of noise. In my analysis, I found that we need a system that doesn't just look for non-threats, but one that actually learns what normal traffic look like, so it can spot even the smallest anomalies in real time. Let's go to the next, to the methodology. So how do we solve this? The research analyzes an ensemble machine learning approach. Instead of relying on just one algorithm, we use a combination like random forest and gradient boosting. I analyzed this methodology and found it to be very effective because it used something called MEST. That's its fancy way of saying the system sets a dynamic threshold. If the network traffic starts acting weird, the threshold adjusts automatically to catch the industry. So with the AWID data set and tools like Wireshark, Wireshark to train this model, the results were quite impressive. That in several models achieved an accuracy rate between 91% and 99.5%. That means the system could identify regular access point, fake Wi-Fi signal set up by hackers almost every single time. My analysis of this result is that the high accessory proofs machine learning is no longer just a concept of networking. Is it a ready to use tool? However, the achievement is only how as good as the hardware it runs on. If the router isn't powerful enough to run the ML model, the security won't work in real time. And let's talk about the future direction. Looking ahead, the author suggests moving toward edge computing, where the security habits right at the router level. If I were to continue this research, my suggestion would be to focus on differential machine learning. We needed to make sure that hackers cannot fool our AI by sending it fake data to make it think an attack it is actually normal traffic. And in conclusion, as we toward Wi-Fi 7 and the Internet of Things, static passwords are not enough. So we need to decision intelligence provided by machine learning to keep our wireless world safe. Thank you for your time and have a good time.